Alright, section 6.5, solving exponential equations. I got one vocabulary term for you, exponential equation. Shouldn't be too difficult of a vocabulary term. The definition should make a lot of sense. An exponential equation is simply an equation where the variables occur as exponents. So we've been working with exponential functions where our x value has been an exponent. So an exponential equation really isn't any different. One property that we need to discuss is the exponential equation property of equality. And what the exponential equation property of equality says is that if b to the x is equal to b to the y. Okay, so if you've got exponential expressions on both sides of your equation, if b to the x is equal to b to the y, then what we can say is that x is equal to y. And this is an important property because this is what we're going to use to solve a lot of the equations we're going to get today. The one thing that you should notice, in order for this property to hold, the base, this one and this one, has to be the same. Okay, the two bases have to be the same. If you've got something like 3 to the x equals 4 to the 7th, we can't say x is equal to 7. It doesn't work that way. Okay? But if we had something like 3 to the x equals 3 to the 6th, then we could say that x is equal to 6 because my bases are the same. So if your bases are the same, then you can just set the exponents equal to each other and solve from there. If the bases are not the same, like in this one, this example that I wrote here in black, if the bases are not the same, notice it's 3 and 4, not the same, then what we can't say is that x is equal to 7. We can't set the exponents equal to each other. But if the bases are the same, like 3 and 3, then we can set the exponents equal to each other. X equals 6. Now if this was, let's say this was 2x, then we could say that 2x is equal to 6 and solve from there. Okay? So, the key with the property of equality here is that the bases have to be the same, and if they are, then the exponents are equal, and we can set the exponents equal to each other and do any solving that we need to. Okay, so let's try a few. Number 1, we've got 2x, not 2x, 2 to the x is equal to 2 to the 5th power. This one is pretty darn simple. My bases are the same, they're both 2, so what we can do then is just set the exponents equal to each other. X equals 5, and we've solved, because when we're solving we want x equals something, whatever it's equal to, and we've got that already. X is equal to 5. We're done with number 1. Pretty simple problem. Let's try another one here. Number 2, 3 to the x plus 1 power, x plus 1 is equal to 3 to the 5th power. Okay, so again, our bases are the same, so we can set our exponents equal to each other. X plus 1 is equal to 5, and now this is just a one-step equation. In order to get rid of the plus 1, we subtract it, minus 1, x is equal to 4. Okay, so it works really, really that simply. Let's try another one here, maybe slightly harder, we'll see. 6 is equal to 6 to the 2x minus 3 power. Okay, well, we don't have an exponent right here. If we don't have an exponent, what we can assume, though, is that it is 1. Okay, so now, bases are the same. Go ahead, set the exponents equal to each other. 1 equals 2x minus 3. And now we've got a two-step equation. Let me slide that up. We've got a two-step equation. We've got 2 steps. Got to add 3 to start with. Got to get rid of this minus 3 by adding it. So 1 plus 3 is 4. So 4 is equal to, move that over. 4 is equal to 2x. And then one last step, divide by 2. And we'll find that x is equal to 2. Number 4, 7 to the 3x plus 5 power. Ooh, let's try that again. 3x plus 5 power is equal to 7 to the x plus 1 plus, maybe, plus 1. Okay, so 7 to the x plus 1 power. Again, bases are the same, they're both 7, so we can just set the exponents equal to each other. 3x plus 5 is equal to x plus 1. Sorry for the handwriting. We've got variables on both sides, so I'm going to choose to take this variable here, this x, and move it that way, and then I will take this 5 and move it that way. I'm going to do that by subtracting x and subtracting 5. Minus 5 minus x. 3x minus x is 2x. Those cancel. 1 minus 5 is negative 4. And then a two-step equation, or one-step equation from there. Divide both sides by 2. X is equal to negative 2. Okay, so there's your answer for number 4. Now, let me show you something a little more difficult. Number 5. Okay, what if the bases aren't the same? What if I said 5 to the x is equal to 125? Okay, we have an issue here because right now our bases are not the same. 5 and 125. Clearly not the same. Could we rewrite the bases so that they are the same? And the answer here is yes. Okay, the base that they have in common is 5. So we can make this 5 to the x is equal to, well, how could we rewrite 125 using 5 as a base? The answer there is 5 to the third power. Okay, because 5 to the third power is 125. Because now we've got the same base, 5. We can just set the exponents equal to each other, x equals 3, and we're done. There's nothing to solve for with number 5. Let's try another one here, number 6. Something with unlike bases. We got 4 to the x is equal to 2 to the x minus 3 power. Again, we don't have the same bases. 4 and 2, not the same. But if we think about 4 and 2, are they both powers of the same base? The answer again is yes. Okay, 4, we could rewrite 4 as 2 squared, and then that is also to the x power. Just rewriting 4 as 2 squared. 2 is already the base, so we don't need to change anything with the second side, or the right side, x minus 3. Okay, well, how does this help us solve? Well, we've got power to a power. We've got two exponents right next to each other, and if they're right next to each other, all we need to do is multiply them. Okay, so 2 times x gives me 2x, multiplying these two right here, 2 times x. Okay, so we'll have 2 to the 2x power is equal to 2 to the x minus 3 power. Now the bases are the same. Okay, they're both 2. So now we can set our exponents equal to each other. 2x is equal to x minus 3. And it's really a one-step equation from here. Subtract x, 2x minus 1x is x. Those cancel. Still have this negative sign though, right here. Okay, so our answer is negative 3. Let's try one more here. This is number 7. Rewrite that in black. Number 7, we've got 9 to the x plus 2 power is equal to 27 to the x power. Now, in these two examples up here, one of the bases, this one and this one, there it is, those two were already the base that we need to use. In this example here, neither of those bases are actually going to stay what they are right now. If you look on your half sheet, the sheet that's got all the perfect powers, what you're going to find is that 9 and 27 are in the same row. And remember, rows go this way, left and right. Okay, so what you're going to find is that 9 and 27 are both powers of the base of 3. So 9 would be 3 squared. 27 is 3 cubed. Okay, so then we'll bring in the remaining exponents, x plus 2, x, set them equal to each other. Okay, this side, the right-hand side, is going to be pretty easy to simplify. It's just power to a power, just like, where was it? Just like these. Okay, power to a power, we just multiply. So 3 times x gives me 3 to the 3x power. The right-hand side is a little more complicated, not a whole lot. It's just distributive property. We still need to multiply, but it's going to be distributive property. So we'll have 3 to the 2 times x power is 2x, and then 2 times 2 gives me plus 4. Okay, so now what we've got is the bases are the same. They're both 3. See, they're both 3. So now what we can do is we can set the exponents equal to each other. 2x plus 4 is equal to 3x. Now we can solve. Since the variable is alone over here, I'm going to take this variable here, the 2x, and bring it over here to the 3x. I'm going to do that by subtracting it since it's positive 2x. Subtract 2x. So I'm going to slide that up again. The 2x is canceled there, just left with 4. 3x minus 2x is 1x, and we are done solving. Let's try another one like that. I'm going to just do that below it here. Where am I at? Number 8. Let's go with 1/2 to the x power is equal to 4. Again, another example of where neither base is going to stay the same. How can we, or what base would work? The base that's going to work here is actually going to be 2. Because if you remember, the negative first power, so negative 1 power, means reciprocal, which means flip the fraction over. Okay, so the reciprocal of 1/2 would be 2, which means we're going to make this 2 to the negative first power to the x power. 4, that is 2 squared. And again, that'd be 4 to the first, so 2 to the second, and then to the first power. Again, same thing here. Multiply your exponents. Negative 1 times x is negative x, is equal to 2 times 1 is still 2, so we're just 2 squared. Okay, now that we've got the bases the same, I'm going to write this out here off to the right. We can set our exponents equal to each other. Negative x is equal to 2, and then it's just one step equation from there. Divide both sides by negative 1. X is equal to negative 2. Let's try a couple more here, and then we'll finish up. Number 9. We've got 4 to the x plus 1 power is equal to 1 over 64. Again, 4 and 64 do have the same base. The base here is actually going to be 4. Okay, so we'll do this in green. 4 to the first, and we'll see. 64 would be 4 cubed, but it's actually the reciprocal of 64, so it's probably going to be 4 to the negative third power, and then that would be to the first. But if it's to the first, we really don't need to write it, so we'll just leave it as 4 to the negative third, and then we got to bring in our these exponents here, x plus 1. Okay, so on the right-hand side, or sorry, the left-hand side, this, remember that's just distributive property. 1 times anything, though, is not going to change it. 4 to the x plus 1 power is equal to 4 to the negative third power. Again, we've got the bases are the same now, so we can set our exponents equal to each other. X plus 1 is equal to negative 3. One-step equation from here, subtract 1. Negative 3 minus 1 is negative 4. It's just a coincidence that we're getting negative 4 and positive 4 a lot. I doubt that you're actually going to see that a whole lot. Let's try one more here. Last one. Number 10. So we got 1/3 to the x minus 1 power is equal to 27. All right. The common base here is actually going to be 3. Okay, so this will be 3 to the negative first power. Reciprocal of 1/3 is 3. And then we got x minus 1 here. 27 as a base of 3 would be 3 to the third power. Okay, really don't need those parentheses. I can erase these. Okay, we can erase those parentheses because we're not going to be raising anything. We're not going to be raising this to any power out here, so we don't really need the parentheses. We do need the parentheses here, though, because this is going to be distribution. Okay, so we get 3 to the negative x plus 1 power is equal to 3 to the third, and then we can, since we have the bases the same now, we can just drop them and set the exponents equal to each other. Negative x plus 1 is equal to 3. Two-step equation here, we'll subtract 1, so negative x is equal to 2. Divide by negative 1 gives us x equals negative 2.